students, welcome to the class. So today we are going to discuss about a very important concept, that is a free body diagram in 8th class. Okay, so as a term indicates, it is something related to a diagram. Okay, so generally when we are going to use this FBD, so when we have a body and when a single force is acting on it, then there won't be any kind of confusion. Okay, so we are going to discuss about that single force and we are going to discuss about the motion of the body. But instead of that, more than one forces are acting on the body, then sometimes it will lead to a confusion. Okay, so we want clarity about the total forces which are acting on that body. So the diagram which shows all the forces acting on a body at a particular instant of time is what we call as a free body diagram. So let me write what is a free body diagram. The diagram which shows all the forces acting on a body at particular instant of time. Instant of time. Now after showing all the diagrams, okay, that is all the forces which are acting on the particular body, we must know the concept of net force. Okay, so the next important definition is the net force here. Okay, so we generally write F net. So what is a net force is, when we take into consideration all the forces which are acting, we are going to add all the forces, okay, depending upon their directions. Okay, so that is what we call as a net force. Okay, so we can define it like this: the algebraic sum of forces acting on a body. Acting on a body is called net force. It is denoted as F net. Okay, and that is free body diagrams you can show as FBD. You can it's abbreviated as FBD. Okay, children. So these two are very, very important. So free body diagram, the diagram which shows all the forces acting on a body at a particular instant of time, and the next important is the net force. The algebraic sum of forces acting on a body is called net force. Okay, so generally when two forces are acting in the same direction, or two or more forces are acting in the same direction. Okay, so let us see what is the how do you show the free body diagram and the net force. Okay, so when forces are acting on a body in same direction. So let me say there is a body, children, here. One force is acting in this direction, that is F1 is 10 newtons. Okay, and there is another body, another force which is acting, F2. This is 20 newtons. Two forces are acting on a body in the same direction. Okay, so now this diagram which is showing the forces which are acting on this body, this diagram is generally what we call as free body diagram. Okay, and what is the net force is, the algebraic sum of the forces acting on a body is called the net force. Now when the forces are acting on a body in the same direction, then F net is obtained by sum of forces. The sum of the forces means, what is the meaning of this is F net. Let me write F net here. F net is F1 plus F2. F1 plus F2. That is, since the two forces are acting in the same direction, so we are going to write 10 plus 20 30 newtons. 30 newtons. And what is the direction? Left to right. Left to right. Okay. So that is a net force. Okay. The diagram which is showing the forces which are acting is called as a free body diagram. It's a very simple concept. Okay. And the net force is a 30 newtons which is acting from left to right. Now, suppose, let me say, when the forces are acting in opposite direction, when the forces are acting in opposite direction, then F net is taken as difference of the two forces. Difference of forces we can take. If you have two forces, difference of two forces. More than two forces, all the forces which are in the same direction you have to consider. Okay, then you have to finally subtract. Let us see that. This is the body, and let me say F1 is 20 newtons and F2 is 10 newtons. See children, here the two forces are opposite in nature. So therefore, what is F net? How do you calculate F net? Difference of the two forces. So 20 minus 10 is 10 newtons along right side. You have to just show the direction also, okay, in which direction the force acts. Now let us see some more examples through which we can understand the concept of net force very clearly. Let me take the third example here. So F1 20 newtons, F2 20 newtons. So here what is F net? So it's very clear, F1 minus F2, that is 20 minus 20, that is 0. Okay, the F net is 0. Two forces are acting on it, but if you try to understand what is the total force acting on that body, then the total force acting is 0. No force is acting on it. Okay, so here you can see that there is some value here. Okay children, so here it is 10 newtons and here it is 0. So here whenever we get some value for the total force, then we call that as unbalanced force. Unbalanced force. Okay, and whenever the F net is 0, we call it as a balanced force. Balanced. Okay, so in order to understand the motion of any body, the concept of this unbalanced force is very, very important. Okay, now we'll go and try to see some other examples. Fourth, now let me say F1 10 newtons, F2 15 newtons, and we have F3 20 newtons. Okay, so what is F net? F net. These two you are going to add, F1 plus F2 minus F3. Okay, so 10 plus 15 minus 20, 25 minus 20, that is 5 newtons towards towards right. Okay, so you can show like this, towards right, that is 5 newtons. Okay, right. Let us see. So far you have been we are discussing about the forces along horizontal direction. Now let us see some along the vertical direction, children. Like this is we have one body, and this is 80 newtons, and this 60 newtons. Okay, so what is a F net? Suppose I'll take this as F1 and this is F2. Okay, so F net, F1 minus F2. If here we have 80 and this is 60, okay, we are going to take that is 80 minus 60, right? So 20 newtons. Okay, now as the magnitude is great here, downward, so we are going to take then F net, that is 20 newtons in the downward direction. Okay. Now let us go for some other examples. Suppose F1 is 20 newtons, F2 is 40 newtons, F3 is 60 newtons, okay, and 60 newtons, 40 newtons. If this is the free body diagram, okay. Now let us try to find out the F net, children. So here you have to consider, previously we have seen the first 3 examples, we have seen the body is moving in a horizontal direction, and this is the forces are along the vertical direction. Now coming to here, we are having horizontal as well as vertical. So in these cases, what you have to do is you have to calculate F net along horizontal separately, that is x axis, and vertical, that is y axis separately. Okay, so we'll write along x axis, along x axis. Okay, what is F net? Along x axis, that is this. Okay, so we have F1 and F2 in the same direction, so we are adding. Okay, and this is opposite minus F3. So we have 20 plus 40 minus 60, that is 60 minus 60 is equal to 0. So F net is equal to 0 along x axis. Okay, right. Now along y axis, along y axis, that is this. So F net, let me say this is F4 and this is F5. Okay, so we'll take F4 minus F5, that is 60 minus 40, 20 newtons. Okay, upwards. So here we have unbalanced force, unbalanced force, and here it is balanced. Generally wherever we see this unbalanced force, there we can see that the body, there is chances the body can move in that direction. Okay, right. Now let us go for the another example. Seventh example. Draw FBD for a car which is at rest and which is let me take separate children first at rest. Okay, then we'll take here, in this case we are going to take car moving with non-uniform motion. Draw FBD for a car which is at rest. Here we are going to see the car which is at rest, and here for the car which is moving with non-uniform motion. Okay, right. So let me draw a car, children, first. So this is one car, and let me say one person is sitting here. Okay, children, now when we look at the car, the first force, so it is this body is, the car is not moving, the car is at rest. Okay, now let me draw all the forces which are acting on the car. So first of all, we know that the weight of the car is acting in a downward directions. Okay, weight is acting downward direction. And in the picture, actually we have 4 tires, but in the picture we can see only 2 tires. So I am going to take a normal force only in case of the 2 tires. So this is N1 and this is N2. Now still, are there any forces which are acting on children? No. So the forces are only along y-axis. Okay, why? Because the body is at rest. The car is not moving. Okay, right. So along y-axis. Okay, what is F net? F net is equal to, okay, children. So W always generally, that is when you look at this y-axis, this is x-axis. This side you are going to take as positive, and this side you are going to take as negative, and upwards you are going to take as positive, and downwards you are going to take as negative. Okay, so here N1 and N2 are acting in upward direction, so I am going to take N1 plus N2. Okay, and weight minus W. So this is a net force acting on the car which is at rest. Okay, now let us see when the car is moving with uniform motion. Okay, let me say that the car is moving in this direction. I forgot the tires. Okay, right. Now, as usual, N1 and N2 I can draw here N1. This is N2. These are the normal forces which are acted on the tires by the road. Okay, children. And the weight is acting in a downward direction. Okay, this is along a vertical axis. Now, the car is moving with a non-uniform motion. Okay, children. So, a force is acted by the engine in the forward direction. That is what I call as F. Okay. And as the car is moving in the forward direction, a frictional force is acted on the car, that is on the tires, in the opposite to the direction of this F. That is small f. Okay, so here the capital F is a force exerted by engine, and small f is a frictional force. W is the weight of the car, N1 and N2 are the normal forces. Okay, so I hope you understood this. Right. So in case of y-axis, this is applicable here also. Okay. Now along x-axis. Along x-axis. Okay. Now this is applicable in case of the y-axis, the same. Okay. Now coming to the x-axis. F net. F net is right side, we are going to take positive, so capital F minus small f. So this is the net force acting along x-axis as well as y-axis. Okay, and actually if you take numerical values, children, you will understand that capital F minus small f will have some value here. Okay, some magnitude we have. Because of that, the body will be moving in a non-uniform motion. Means a unbalanced force is acting. So generally here you can see that it will be 0. Okay, why? Because there is no motion in upward or downward direction. So here it will be 0. But coming to here, it won't be equal to 0. So this is an unbalanced force. This will be a balanced force. Okay, these are some examples. Okay, where we could understand the free body diagrams. Okay, next we will go for the concept of pressure. Okay, children, now let us try to see the other concept, that is pressure. Okay, children, so before I define what is pressure, let us try to see some simple activities like let me say I am going to take the pen like this, okay, and keep the cap back set like this. So I have a pointed end and I have the end with the cap. Okay, so now what I am going to do is I am going to start with the cap end. Okay, so I am going to press, I am going to apply force on my palm with the cap end. Okay, so first I am going to apply a force of 10 newtons. Okay, I am going to apply 10 newtons. Next I am able to bear the force. Okay, right. Now I am going to increase the force. I am going to make it 20 newtons. So when I am applying 20 newtons also, there is not much pain caused to me. Okay, I am able to bear the pain which is given by that force. Okay, now what I am going to do is I am going to turn the pen like this. Okay, now this pointed end I am going to keep on the palm like this, and now I am going to start the exerting the force. Okay, so first initially I applied 10 newtons, then I make it 20 newtons, right, in the previous case. Now as I am applying a force of 3 newtons or 4 newtons, then what happens is that I am unable to bear the pain. Why? Because the pain is increasing. Why? Because the effect of force is increasing here. Okay, so I am unable to bear it. I'll just remove my hand here like this. Okay, so here initially, so why the effect of force was very great? In the beginning, the effect of force was very less in the beginning, but in the second case, the effect of force is very high. Okay, so what made the effect of force so high? Okay, so if you look at the pen, children, this end, the end with the cap, okay, and the pointed end, the area of contact is different. Okay, here the area of contact is more. The pen end, the cap end, the area of contact is more. So if the area of contact is more, the effect of force was less. And when I come to this pointed end, the area of contact is very less. So if you look at this area, the pointed end, the area is very less. How much part of the pen is touching my palm, children? Very small area. So the area of contact is very less. When the area of contact is less, the effect of force is less. Okay, so we could understand like this, that is as area of contact is less. Okay, so effect of force is high. Okay, if area of contact is more, so effect of force is less. Okay children, so this effect of force what I am talking about is what we call as pressure. That is what we call as pressure. Okay children, so when I am applying a force with this cap end, as the area of contact is more, the pressure is less. Okay, the area of contact is more, effect of force is less, that is the pressure is less. Okay, actually there is no direct meaning for pressure. Okay children, so in order to understand pressure you have to understand this small example which you are taking here. Okay, now here when this I am turning, that is the pointed end when I am putting here, and when I am exerting force, okay, the area of contact is less and the effect of force is high. So as the area of contact is less, I can say the pressure is high. Okay, so we can define pressure as, we can define now, pressure is defined as force acting perpendicular to unit surface area. Okay, so pressure is defined as a force acting perpendicular to the unit surface area. So pressure is equal to force per unit area. Okay children, it is defined as a force acting perpendicular. So this term is also very important actually. So it may be defined like this children, thrust also you can say, thrust per unit area. And what is the meaning of thrust is perpendicular force. For example, if you take any surface, if this is a surface, the force should be taken like this. That is, it should be 90 degrees. Okay, this is called thrust, or the force acting perpendicular to unit surface area. Okay, the force should not be acting like this. You are not going to consider like these forces. Okay, you have to consider the force which is perpendicular to the unit surface, and that is what we call as pressure. The pressure is defined as the force acting perpendicular to the unit surface area. Okay, right. Now, what is the CGS unit? The CGS unit. Okay, the CGS unit of force is dyne. Okay, and what is the CGS unit of area? It is centimeter square. So we can write as dyne per centimeter square. Okay, and SI, the SI unit of force is Newton. Okay, by area. What is SI unit of area? Meter square. Newton per meter square. Okay, CGS unit of pressure is dyne per centimeter square, and SI unit is Newton per meter square. And this Newton per meter square is also called as Pascal. Okay, PA. Pascal is also unit of pressure. Okay children, so how do you define pressure? The pressure is defined as force acting perpendicular to the unit surface area. So pressure is called force per area, right? Now, if you look at the formula, pressure is equal to force per unit area. Look at the relation between the pressure and the force. Okay children, as F, so we can say as P is proportional to F. Okay, directly proportional. The pressure and force are directly proportional. What is the meaning of this? As F increases, P also increases. increases and vice versa. That is, F decreases, P also decreases. Now, as see the relation between the pressure and area, inversely proportional to area. Inversely proportional to area. Okay. So, what is the meaning of that? As area increases, P decreases. Okay, as A increases, P decreases, and as A decreases, P increases. Okay, children. So we have been talking about this first small activity which we have seen. If you take a pen, and as I am pressing, children, here, as I am pressing here, the area, okay, so the area is less. When the area is less, okay, area is decreased, P is increasing, effect of force is increasing, and when the area is increasing, the effect of force, that is the pressure, is decreasing. Now, if you look at this formula, children, so if you want to calculate force, then pressure into area, and if you want area, force by pressure. These are the formulae which you have to know it. Okay, these are derived from this. P is equal to F by A. Okay, and let me take few examples. For example, if you take the example of a student who is carrying a bag. Okay, if you look at the straps of the bag, children, the straps of the bag, when the student takes the bag, if the straps are broad straps, okay, then he do not feel lot of strain on his body. Okay, but if the straps are of less area, they are very thin, let me say, then there will be lot of pain on his shoulders. Okay, if the straps are wide enough, then there is no pain on the shoulders. But if it is if the straps are very that is, if it is very that is, the area is very less, then it gives a very painful experience for the student. Now here the same thing, children, the weight of the bag is same. Okay, the force is same. Okay, the force is same. The force exerted by the bag, that is, the weight of the bag is same. But coming to the area of contact, if the area of contact is more, then the pressure is less. That's why the pain is less. Okay, if the area of contact is less, then the bag, wearing the bag will be very painful experience. Okay, we have so many that is examples in our day-to-day life. For example, if you take a tractor, okay, children, if you take a tractor, the rear tires of the tractor are very broad. Okay, why? Because the tractor generally works in the field. Okay, and when the tractor is working in a field, the amount of pressure or the amount of force which the tractor exerts should be very, very less. If not, what happens is that there is 100% chances that the tractor gets struck in the fields. Okay, generally the soil itself is very soft there, and 100% chance is there for the tractors to get struck there. Okay, so in order to reduce the pressure, we are increasing the area of the tires. We are making it broad. Okay, not only that, we can see so many lorries which are carrying heavy loads. Generally the tires will be very broad, and large number of tires we have. Okay, so that is one example, and you can also write so many examples, children, in the kitchen. Okay, in the kitchen, if you look at a knife, now this is opposite. Okay, if you take a knife, how is the end of the knife? If you take a knife and we have a sharp end, we have a blunt end. Okay, with the sharp end, when you are cutting any vegetables, it will be very easy for us to cut. Why? Because the area of contact is very less, and as the area of contact is very less, okay, what happens? The pressure increases and it will be very easy to cut the vegetables. If you turn the knife, okay, and try to cut with the blunt end, then what happens is very difficult to cut. Why? Because the area increases, then the pressure will decrease and it becomes very difficult to cut the vegetables. Okay, so that is the effect of area, children. Okay, so if the area is more, the pressure will be less. If the area is less, then the pressure will be more. So depending upon the situations, okay, in case of the knife, we want more pressure. That's why you are reducing the area. In case of the tractor, you want less pressure. That's why you are increasing the area of the tires. Okay, children. So let us see one numerical problem here. Weight of body is 50 newtons. Calculate pressure when it rests on one side with surface area 10 meter square. Also find pressure when surface area is 20 meter square. Okay, children. So let me take that. Suppose we have one body. Okay, this body. The weight is 50 newtons. Okay, now newtons. Okay, so we are talking about the area of contact. Here area of contact and here area of contact is different. Okay, children. So first we will contact, that is the first case when area is let me say 10 meter square. And what is force? That is weight. That is how much? It is 50 newtons. 50 newtons. So what is pressure? Pressure is called force per unit area. That is 50 by 10. That is 5 Newton per meter square. Okay. In the second case, we will see here. Second case, when area is 20 meter square. So F is equal to W is equal to 50 newtons, right? So let me do it here. That is the second case when area is 20 newtons, 20 meter square. So pressure is equal to force per unit area, 50 newtons by 20. So here you are getting 2.5. So what is pressure is equal to 2.5 Newton per meter square. See children. So when the area is 10 meter square, here area is 20 meter square. So when the area is 10 meter square, you have got pressure as 5 Newton per meter square. When the area is increased, area is doubled, then you have got that is the pressure is reduced to half. Okay, so you can understand the effect of area here. Okay, so the force exerting per unit area is what we call as pressure. Okay, and the pressure, the value of pressure is directly proportional to the force applied and is inversely proportional to the area of that body. Okay, okay children, so finally let us see one small activity. Already we have seen so many problems and we have understood the concept of pressure. So this is a small activity. Let us see once again. So take 2 trays and fill them with fine sand. So you have to take 2 trays like this. I have shown it as like this 2 trays you have to take. Okay, and take 2 bricks of equal size and equal masses. So you have to take 2 trays like this. Let me say 2 trays you have to take and fill them with sand. And fill them with sand like this, and you have to take 2 bricks. You have to take children. You have to take 2 bricks of same size. You have to take 2 bricks of same size, and keep 1 brick horizontally in 1 tray like this. You have to place it like this, 1 brick horizontally. Okay, this is vertically, and other brick vertically. Okay, this is vertically and this is horizontally. Okay, children, you have to place it like this. So then what you can observe is that observe the pressure in both the trays. Okay, this is a very simple activity, right? When placing the bricks, one is vertical, another one is horizontal, like this. Then after that, what you can observe is that you can observe the pressure in both the cases. Okay. So what is that you will observe? You will observe in the first case, that is, it is going to more deeper. Okay, when we compare to the second one. Second case, it goes less deeper. Okay, in the first case, the A goes more deeper, and here it goes less deeper. Now here, what is the reason here? Brick, what is the observation? Okay, so brick A sinks deeper than B. Brick A sinks deeper than B. Now, what is the conclusion? In first case, as area of contact is less, pressure is more. So here, area of contact is less, therefore the pressure is more, therefore it is going more deeper. In second case, as area of contact is more, the pressure is less. So you can understand that. Okay, area of contact is more, the pressure is less. In both the cases, magnitude of force is same. Okay, that is the weight of A and B. The weight is same. Why? Because you have said equal size and equal mass. The weight is same. But due to difference in the area of contact, the area of contact is different. The pressure is different in these two cases. Okay, children. So this is a small activity which is prescribed in your note in the textbooks, children. So I hope with the formula, okay, and by numerical problem, and by taking different examples, and by looking at this activity, I hope you have understood the concept of pressure.
Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.